All right, here we go. For this study guide, you're gonna need patty paper. So if you ever do need patty paper, just grab some from my classroom, or grab like a piece, I should say, from my classroom. If you want to do the homework and you don't have like the tracing paper called patty paper. So if you ever need some, just feel free to grab one. All right, here we go. I'm gonna go grab a piece and then we'll get going. Love this stuff. Again, $9 for 1,000 sheets. If you're not doing your homework, that's a problem. And if you're not doing your homework because you don't have materials, just come see me. All right, here we go. Unit 1 exam study guide. So let me tell you a little bit about this. What I do, well, number one, I love to help people. And that's one of the reasons I'm a teacher. But what I've done is I took a look at all the problems on the Unit 1 exam, and I went through the workbook and I found the ones that I felt were like most related to those problems. So this study guide is basically gonna help you prepare for the test in addition to what you've already learned. So there's no way for me to cover like every single thing that we covered in class, of course. That's really on you. I can't cover it in a video though. That would be silly. It'd be 3 hours long. But I do want to focus on a few problems, and then I feel like you'll be okay if you focus on these problems in addition, like I said, to what you already learned. So here we go. The first one is on page 17. It is practice problem number 2, and it says, in the construction, A, right here, is the center of one circle, and B is the center of another. Identify all segments that have the same length as segment A, B. This one is all about the radius AB. So let me go get my favorite pen. Be right back. Okay, so you'll see that both circles that they talked about share a radius, AB or BA, whatever you want to call it. So that means that any radius of this circle will have the same length as any radius of this circle. So therefore, AC, BC, BD, and AD will all be the same length. So you could like put little hash marks. Now, how do I know that? Well, that's because I know that each one of these is a radius. These two are radii of the circle with center B. These two are radii of the circle with center A. So AC, BC, BD, and AD are all going to be the same length. All the other ones are irrelevant as far as I'm concerned. So let's see what the choices are. So got to identify all. AC, yep. AE, oh, I missed one. AE is 2. Why is AE? Well, it's a radius of the circle with center A. So yeah, AE is good. Let's look at BC. Yep, BC is. How about CD? No, that is not a radius of either circle. And finally, DE, that's another no, because it is not a radius of either circle. So ABC. Okay, at page 23. This is also, coincidentally, practice problem number 2. So in this diagram, well, first of all, they give you this. AB is perpendicular to CD. So there's that little 90-degree angle. That just means that you have two lines, and where they intersect forms a 90-degree angle. That's what perpendicular means. And this is your symbol right here for two lines that are perpendicular. This is the symbol for a right angle. Okay, so line segment CD is the perpendicular bisector. That's a good one. Such a good one. I'm going to underline it twice. So it's the perpendicular bisector, so CD, perpendicular bisector of line segment AB. Remember, line segment, starting point, ending point. Use a straight edge always, but anyway, this is like a line segment versus a line has arrows extending in both directions. And last but not least, a ray starts at one point and then extends in one direction forever. So those are the differences. You just need to know what those mean. It's really important. So this line, line segment CD is the perpendicular bisector of line segment AB. Assume the conjecture. That means assume this is true. That the set of points that are equal distance from A and B is the perpendicular bisector of AB. So what they're saying is this line segment CD represents the points that are equal distance from A and B. Is point E closer to A or B? Well, if this is the set of all points that are equal distance from A and B at the same time, then anything to the right of the line will be closer to B. Anything to the left of the line will be closer to A. So because E is to the left of the line, it is closer to A. E is closer to A because CD represents the points equal distance from both A and B. And E is to the left of CD. That's how I would answer it. Okay, let's move on to the next. Page 29. So this is practice problem number 1. and it says on page 29, it says this diagram is a straight edge, see those straight lines, and compass construction. So that means the circles are perfect, the lines are straight, they're not hand drawn like that, and my circles are not like this. I actually used a compass, or this image, they used a compass. So let's try to duplicate it. We'll see if we can. It's always fun. Hang on one sec. Yeah. So that's how they built these, essentially, is what it's saying. Perfect circles, perfectly straight lines. Don't hand draw lines or circles, please. I have to take off points if you do. All right, the diagram is a straight edge and compass construction. A is the center of one circle, B is the center of the other. Explain how we know that this triangle, ABC, in orange, is equilateral. I'm gonna go turn the lights on. But before I do that, I want to show you one thing. So an equilateral triangle, all sides have the same length. All the angles are 60. So how do we know that this is in fact an equilateral triangle? So, cool, lights are on. Much better for videos. But anyway, how do we know this orange triangle is equilateral? To prove that a triangle is equilateral, you just gotta prove that this side, and this side are the same length. You could go angles too, but we'll get to that later. Right now, we're just gonna prove that the sides are the same length. So I'll show you. It's very similar to the last concept, but you'll see both of the circles share AB as a radius, which means that any radius of this circle, literally any of them, will be the same length as any radius of this circle. Now, there's a radius, AC. So we know AC is in the club. AB, AC, both radii of circle center A. Let's look at this one. BA and BC are both radii of the circle with center B. So you can conclude that that equals that, which equals that. So we got all three, so we're done. Now we just have to write a sentence. So you've thought about it now. Now you gotta write the sentence. Hey, I'm recording a video, I don't have time. Is that okay? Okay, catch me before class, okay? All right, thank you. So we know triangle ABC is equilateral, and this is one of the most important words in geometry because it's one of my favorite words. We know triangle ABC is equilateral because BC BA and AC are all radii of circles with the same radius, and that is AB or BA. That's what I would have written for that. Okay, here are two polygons. You've got polygon P and polygon Q. Select all sequences of translations, rotations, and reflections below that would take polygon P to polygon Q. So there's a side, there's a side. So here's how you do this. I typically recommend pencil when you're using tracing paper, because if you use pen, sometimes it's tough to write on patty paper for whatever reason. So we've got to do a patty paper filming videos, guys. Anything you need? You good? Oh, you're just looking? Okay, cool. So we got P. And what I recommend you do is draw all the points and literally trace the letters. Big part of geometry is just copying things. Okay, so now you've got this patty paper. Now, I know I need a straight edge, so I'm gonna go get one. That's what I want you to start doing in class. Like, you know you need a tool, just go get it. I'm gonna use one of these shatterproof protractors. Just a reminder, every time you smack this on the desk and break it, it's another like $1 out of my pocket. So please, try not to break these. I only have a limited budget for materials. All right, so polygon P, remember, we traced. Now you just gotta build the line segments. So there's a tracing of polygon P, as best as I could do. As long as you start with the points, that's the easiest way to do it, just to trace it. Okay, so we got to select all. So we got to figure out which ones go from P to Q. So rotate 180 degrees around point A. Now, when I see that, the first thing I think is, okay, use these equilateral triangles to help you, because we just learned equilateral triangles are 60 for each angle. So 60, there's 60. We got to go 180 though, and it doesn't matter which direction, because that's the one exception where it doesn't matter the direction when it's 180. That's 120 because we went 2 triangles. This, sorry, right there is 180, which means we've got to look at the polygon Q, which is there. So no, A is a no. This one is definitely not going to work. Now let's look at B. So we're going to start here again. They tell us to rotate 60 degrees counterclockwise. So a clock hand always goes this way. That's a clockwise. Counterclockwise, we're gonna go this way. Geez, I'm totally messing up. That is still clockwise. Wow. So sorry, we're gonna go this way. Guess it's one of those days. Anyways, counterclockwise goes against the hands of the clock. So here we go. Rotate 60 degrees. See, everybody makes mistakes, even your teachers. All right. 60 degrees counterclockwise around point A, and then reflect over FA. So the final move, we're gonna reflect over this line. I'll show you how to do that. So if we go 60 degrees counterclockwise with center A, do you see this line, BA? Do you see this angle right here? That's 60 degrees, right? Equilateral triangles. So if we go 60 counterclockwise, B is gonna land on F. So we're here. Now you can already tell this isn't gonna work because I know I gotta go over this line right here. And this is Q. So basically you're gonna reflect and then you'll see. Here we go. We're gonna flip it. And it's going to end up a little bit off. So B is out. Let's do C. Translate so that A is taken to J, then reflect over line BA. That's where you need to know the difference between line and line segment. Line BA goes forever in both directions. Okay, so we're gonna translate, so A is taken to J, then reflect over this line here. That's how you do it. A to J. So you should be here. And then line BA, remember, is this line. So let's see. Hey, we got a winner. C is good. Let's look at D. Reflect over line BA first, and then translate by directed line segment BA. Okay, that's a lot. Let's just chip away at it. So reflect over BA first. So this is BA, line BA. So what's gonna happen is you're gonna be here. And then we got to translate by BA. BA. So you just go B to A. And ta-da, we're good. D is good. Okay, reflect over BA. So they want us to do that again. Let's do that. Reflect over BA. So we're here. And then rotate counterclockwise around point A. So we're here. Remember, this line has to go 60, so use the triangles to your advantage. Gonna end up there. I'm filming a video, so I can't really have any comments. Can it wait till class starts? Otherwise, this is going on YouTube, this conversation. Okay, cool. So E is a no, so C and D are good. All right, next one. We are on page 102. I think that's the next one. Let's just see. Yep, 102. All right, so page 102. Here are two polygons. So you got P and Q. I'm gonna go close my door. Okay, shoot. Sounds like I gave you the answer. Select all P to Q. Wow, I think they use the same exact polygon. No, it's a little bit different. Okay. Looks like your answer is B and E. I guess I could skip that. Let's see. No, I'm gonna do it. I'm not confident that I'm right. Hang on. This would be a good one to like kind of skip ahead for time's sake. I'll give you the answer. You now know how to do it. And now that you have the answer, you'll be able to figure out why. Okay. So here we go. Making mistakes this morning. Oh well. Get used to it. It happens. That's one thing I got to work on myself, and because I preach about it all the time. Just be okay making mistakes. Like, it's not the end of the world. It's all good. Try not to let it stress you out if you make like little mistakes, like I do all the time. You can drive yourself crazy if you're so self-critical in your own head. But anyways, there's polygon P. Just get rid of all the negative self-talk if you can. Let's just see if B and E are correct. Translate, so A is taken to J. So you'd go right there. And then reflect over BA. So yeah, that works. So you're gonna end up there. This one says reflect over BA. Right there. That's why it helps to trace the letters, because you can pick up where you left off if you make little errors. Like for instance, I did a kind of a rapid flip, and then I know it's gonna end up there. And then translate by BA, so B to A. Yeah, that's good. So your answer is B and E for the one that's on page 102. The other ones don't work. Okay, let's skip ahead. We are on page 133. These are fun. I always liked these. This isn't a practice problem. It's actually 19.1. But they say to evaluate the missing angle measures. I've already done this on a video, I remember, but since this is a straight line, it's 180. And this plus this are known as linear pairs. So linear pairs add up to 180 degrees. So if this is 50, then this one right here is just 180 minus 50, which is 130. So here's 30. Again, this represents 180 minus 30, which is 150. And then I'm going to introduce the new concept, vertical angles, right now. So vertical angles, you got a line and a line, and there's a V, and there's an A. That's how I always remembered it. But vertical angles are congruent, meaning like the ones are the same and the twos are the same. Same measure, I should say. So then this one is 30 and this one is 150, and then that one's done. Now this one, figure C, you got to use the linear pairs concept again. So much like this, we just did, to find this one, we just did 180 minus 50. Same goes here. 180, this one's going to be 180 minus 65, which is 115. This one I'm going to use the vertical angles concept. So 135, that's 135. I know that. Then I'm going to go with the linear pairs concept. So this one's going to be 180 minus 135, which is 45. And then I'm going to go back to vertical angles. So if this is 45, then this is 45. And that's it. That's a similar. If you can do these, you should be fine on the question that's on the test. So vertical angles, linear pairs, it's all formed by two lines that intersect. Okie doke. Next one is on page 139. We're almost to the end. I've got 1, 2, and 3 problems. And then got a meeting. Cool thing about teaching is every single second matters. So you got to be on point all the time. It's great. It's fun. So point D is rotated 180 degrees using B as the center. So D is going to go like over here. It looks like it's going to land right on A. So explain why the image of D, what is the image of D? It's going to be D prime. So explain why the image of D must lie on ray BA. So here's ray BA. Starts with B, extends through A, and goes in all directions. Hang on, I just got a really important email. Let me respond to that. Basically, you're going to rotate this whole ray. I'll be right back. Okay, apologies. I had to handle an important email. So, okay, here we go. So ray BD. So let's say we got ray BD. So you got B and you got D. This is ray BD. So explain why the image of D is going to fall on BA. Well, after a 180 degree rotation with center B. Now, if it's 180, you can go either direction. That's the only, well, 360 as well. Multiples of 180 allow you to go in either direction. So 180 or 360 is pretty much the only you'll ever see. But here goes ray BD, which I traced. 180 degree rotation. And there it is. 180 is a straight line. Like, let's look at, that's almost 90. That's about 45. There's 90. There's about 135. About. And there's 180. So, just take a look. Why will D prime always be on ray BA? Because the whole ray BD, when rotated 180 degrees, falls on ray BA. So that's your answer. All right, page 140. Quadrilateral ABCD is congruent. So ABCD is congruent to A prime, B prime, C prime, D prime. Describe a sequence of rigid motions that takes A to A prime, B to B prime, C to C prime, D to D prime. If you say we reflect over this line, you're going to be wrong. Just fair warning. So here we go. A, B, C, and D. Connect your dots. Super easy to do that. It's fun too, especially if you go slow. I'm kind of in a hurry, so just got a meeting in 5 minutes. Okay. I know it's stressful when you're running out of time and you're doing a math test. So I feel your pain. We've all been there. If you need extra time, just come see me. I'm usually gonna say yes. All right, so quadrilateral ABCD, here it is. We gotta get it to this one. So what I always recommend on these is go A to A prime. Just go A to A prime first. So you're gonna be here. Now I see B. This is the translation from this one to here. A to A prime, so translate A to A prime. That's the directed line segment. There's B prime, so that's a big hint. Rotate clockwise, 90 degrees. There you go. They all line up. So, one more time. Translate A prime, rotate center A prime, clockwise, 90 degrees. So, translate A prime, rotate center A prime, clockwise, 90 degrees. How do I know that? Well, look at AB and look at A prime, B prime. That's a 90 degree angle. That's what I'm looking for. Okay. Next up, last one. Sweet. It gives me 2 minutes to get ready for my meeting. All right. Lines L, there's L, and M are parallel in all instances. Evaluate the measure of X in each figure. This is known as a transversal. There's a transversal. Transversal. And transversal. What is a transversal? Well, hopefully the images help you, but it's a line that intersects two parallel lines. If you ever want to go like this to identify parallel lines after it's given to you, you could do as many arrows as you want as long as they match. That's just your symbol for parallel lines. So what happens is transversals cutting across parallel lines creates what's called corresponding angles. And here's an example. If this is 40, then this is 40. So x is 40. Transversal across parallel lines also creates alternate interior angles. So just simply a line cutting across parallel lines. Think of Richmond. We got Bissell. We got McDonald. And then we got let's just imagine Harbor is like a tiny bit off, like it's not perfectly perpendicular. But anyway, this angle, whatever it is always going to equal this. This angle is always going to equal to this. And this angle will always equal this. So the pencil corresponding, the red dot, alternate interior, the orange ones, alternate exterior. And they are all congruent. So this is 61, this is 61. Hang on, someone's knocking. I think that's my Okay, thanks. Oh, it just got loud. Okay, so figure C, 98. This is the one example where these are not the same. These are not the same. These are called complementary angles, and complementary angles add to 180 degrees. So therefore 98 and x, 98 plus x will equal 180. So what you need to do is subtract 98 to both sides. These cancel, x equals 82. 80 plus 2. So x is going to equal 82 degrees. If you ever want to find these, take this one, just go 180 minus this to find this. Those are called complementary angles. And then last but not least is alternate exterior angles. So alternate exterior, if this is 125, this is kind of like the example in orange that I gave you, alternate exterior. If this is 125, you got the transversal, this is 125. Now let's look at what the word alternate means. It's period 2. Yeah, okay, so yeah, alternate sides of the transversal outside, aka exterior, outside the parallel lines. Alternate sides of the transversal inside the parallel lines, interior. Complementary angles, they're on the same side of the transversal. And last but not least, corresponding angles, they are on the same side of the transversal, but one's on the inside, one's on the outside of the parallel lines. Okay, I gotta go, that's it.